Today, we're going to look at function references in Kotlin, and we're going to see how you can change the way that you interact with a function reference just by changing the type of the reference at its call site. This one's fun, so let's get started. As you probably know, there are two flavors of functions in Kotlin. We've got functions that are standalone, that do not have a receiver, and we've got functions that do have a receiver. A quick recap for those who are new to Kotlin: when we're talking about functions, a receiver object is just the object that the function is called upon. So for example, here when we call toRegex, we're calling that function on this string object because we're doing the string and then a dot and then the function name. So in this case, this string here is the receiver of the toRegex call. Other functions don't have a receiver. For example, the countWords function here is an example of a regular standalone function that has no receiver. When you want to call one of these, you just pass all of the arguments between its parentheses, in this case, just text. A function that has a receiver could be a member of a class, or it could be an extension function. This word count function here is an extension function, so when we call it, instead of passing the string as a regular argument between the parentheses, we put it before the function name and we separate it with a dot. So this is the receiver object, and the keyword this here refers to that object when it's called here. So this is what it looks like to call a regular function and a function with a receiver. But instead of calling these functions, what if we want to assign them to a variable? Now, I don't mean assigning the results of calling the function, I mean assigning the functions themselves to a variable. Well, to assign a regular standalone function to a variable, we can use the callable reference operator, which is two colons next to each other, followed by the name of the function, like this. And once we have this, we can call it the same way that we can call the function that it points to. We can just use the variable's name, the parentheses, and the arguments. Now, so far we've been using Kotlin's type inference here, but we can also explicitly specify the type, and that'll be important for some stunts that we're going to pull a little bit later in this video. We can explicitly specify the type of this variable by using a function type, which includes the parentheses, the type of the parameter, an arrow, and the return type. So that's how we can take a standalone function, one that does not have a receiver, and assign it to a variable. Now, when it comes to a function that does have a receiver, we can just use the callable reference operator between the receiver type and the name of the function, like this. Again, we're using type inference here so far. So if we want to explicitly specify the type, we would normally put the receiver type outside the parentheses with a dot, like this. With that, we can call the function on a string object just like with the original function up here. Now, just to clarify the terms, this is a function type, and this is particularly referred to as an extension function type. All right, now what's fascinating here is that we can also call it the same way as we call a function that doesn't have a receiver, just by passing text as an argument between the parentheses. It'll work either way. What's really neat, though, is that these two types are actually interchangeable. So in other words, we can assign the regular countWords function to a variable that has a function type with a receiver. And we can assign the word count extension function to a variable that has a function type without a receiver. Just note that when we do that, we can no longer call it as if it has a receiver, so we're going to put that one back. Now, the ability to change the function type from one that has no receiver to one that does have a receiver has some pretty neat implications. For example, here I'm using the swap case function from the Apache Commons text library. The code down here isn't the easiest to follow because we're combining regular functions with extension functions, so the order of evaluation isn't in just a straight line. So first this is evaluated, and then finally this. So the order of evaluation kind of bounces around. We could use a scope function to insert the custom transform in the middle by doing something like this. And honestly, this isn't all that bad. But it would be even easier if we could just invoke it directly in the chain, like lowercase and replace are doing. But as it is, this won't compile. Well, even though this swap case function is just declared in a Java file, where it just takes a string as a regular argument, we can still get swap case to work as an extension function just by declaring it as an extension function type where we're using it. So in other words, we don't have to change anything in the Apache Commons library, and we don't have to wrap it in an extension function in Kotlin. All we have to do is change the declared type from a regular function type to an extension function type like this. And everything just works. Now, we saw earlier how we can use the callable reference operator with a class on the left and the function name on the right. But if we already have an object, we can use that operator with an object on the left instead of a class. The object on the left here will be used as the receiver object when we call this function. So in other words, we can just call it like this. So unlike the examples above it, we can no longer put a text dot to the left of the function name, nor can we put the text variable inside the parentheses. Each of these things causes a compiler error. So the value of text here is baked into the function reference. And if you're familiar with the concept of partial function application, it's the same basic idea, just working on a receiver object. Because we created this function reference with an object instead of a class name, the type of this function is this without string anywhere in its type. And this is called a bound function reference because the function reference is bound to, in other words, it's tied together with the receiver object. Contrast that with the function reference up here, which is not bound to any receiver object. So a function reference can be either bound or unbound, and that's going to affect its list of parameters. Now we can use the callable reference operator not just on functions, but also with properties. So here I've got a document class that has one mutable property named text and one read-only property named length. Now remember, you can both read and write the value of a mutable property, but with a read-only property, you can only read it. So in other words, a mutable property has both a getter and a setter, whereas a read-only property only has a getter. We can use the callable reference operator to refer to the getter on either of these properties. And to do this, I'm just going to use the operator twice, once between the class name and the property name, and then again between the property name and the word get. And these two are effectively functions that take a document and return the property type. And the setter works roughly the same way, where we would use the word set instead of get. Now, with this setter, can you guess the type of this set story variable? Well, it's a function type that takes both a document and a string, and it returns unit. Now, using an unbound reference with this example code probably wouldn't actually be very helpful. After all, if you have a document object, you might as well just call document.text instead of passing the document to this function reference. Most of the time when working with properties, we'd probably want bound references. So let's update each of these to use a bound reference instead. Now remember, when we do this, the receiver object will be baked into the reference. So these three functions no longer accept a document. So we can get rid of that document part of these. And now the document type is no longer in these function signatures at all. So we get a lot more flexibility since they only deal with strings and integers. We can use these references now in a module of our code that has no concept of a document, or maybe even in a third-party library. But it gets even more fun. This setStory function reference went from 2 parameters to 1, and now that the document object is out of the way, we can choose whether we want this string to be a parameter or a receiver. As we saw earlier, with a regular function reference, we have to pass the argument within the parentheses. But if we change it to an extension function type, then we can either pass it as the first argument, or we can use it as the receiver. So just by changing the way that we refer to the function, we've made it so that we can call a property setter with the syntax of an extension function. Now, to keep things simple in this video, we've mostly used variables for our function references. But in real life, the benefits of function and property references is more often found in higher order functions. So in other words, functions that accept or return another function. So for example, here I've got a class named history that has a constructor that takes a function, and I made t here a receiver type so that I could just do this value.apply. And this works with the setter reference that we've got up here. And of course, this would also work with a function instead of a property. So instead of using the setter of the book's text, we could just even replace this with a print line. And now all of the history changes are just going to be printed to the output. So callable references, including both function references and property references, give us a lot of flexibility, especially when we can use bound references where the receiver type is baked into the function call for us. Well, the end of the year is going to be here before you know it. And as you probably know, we've been publishing new videos every other Wednesday. But if we stay on our current schedule, we're going to end up colliding with Thanksgiving here in the US in a few weeks, and then again on Christmas a few weeks later. So we're going to shuffle things around. We're planning to do a new video again in just 7 days. And then from there, we will resume our semi-weekly schedule. If you want to make sure that you don't miss anything, you can, of course, subscribe to the channel. And you can also join hundreds of other Kotlin developers who have signed up for my email newsletter, and you can do that at newsletter.typealias.com. In the meantime, keep writing that Kotlin code. Thanks so much for hanging out with me today, and I'll see you next time.